Okay, here we go. Sounds good.
Is it recording?
It's recording.
I know.
You're on film. Okay, so let's look at some properties of this quadratic function. Okay, so this is what we want to do today. A function whose f of x, now that just means the y value, okay, at x is given by the polynomial of degree 2. So remember what I'm saying now for a quadratic function is you must have a polynomial with degree 2, meaning you've got to see this x squared now. Okay, so in grade 10 you just looked at x by itself with a line. Now you're in grade 11, you're more sophisticated, you have to look at x squared. Now we already talked about the shape of this function. What is it called? A parabola. Good. So it's called a parabola. And the neat thing about this parabola is if you were to look at it and draw a line straight down the middle, it cuts the parabola into two equal pieces. And so what do we call it in math when we get two equal pieces? It's the idea of being symmetric. And it's symmetric about a line. And there's a special name for the line. It's called the axis of symmetry. Okay, and I'll show you that in a second with an example. So this axis of symmetry will divide the function into two congruent, and another word for congruent just means equal, halves. Okay? And the third point I want to do before we go on to the rest is that it actually has a highest point or a lowest point. So if I were to draw my parabola this way, you see how there's a lowest point? And if I were to draw it upside down like this, can you see how there's a highest point? Well, we have special names for that too. We call it the vertex. Okay? Now, what I'd like to do before we do 4 and 5 is let's just skip down to example number 1. I'd like you to actually graph out this quadratic function by hand because later on I'm going to show you how to do this using a graphing calculator. So what I'd like you to do by hand is this. I want you to make a table of values, so that's the thing in the middle. I want you to plot the points, and I want you to connect the dots together. Okay, once you've done that, let's see if you can answer these questions on the side. What's the y-intercept, the x-intercept, the coordinates of the vertex, and all this other kind of stuff. To help you out, I'm going to ask you to use these x values. So please write them in. -3, -2, -1, 0, 1, 2, and 3. Okay? So the first thing I want you to do is find the corresponding y values. So I'll do the first two with you together. What that means is this is your equation. Let's plug in -3 for x. So what's -3 all squared? 9. Good. So be careful. It's -3 times -3, which is positive 9. How about the next one? -2 all squared. That's 4. Okay. -1 all squared. 1. 0 all squared. 0. 1 squared. 1, 4, 9. Okay? Can you please now take these points and graph them out on the grid? So I'll do the first one with you, -3, 9. And then I'd like you to do the rest. Plot the points, and I want you to connect them together. Please connect them with nice curves. Okay, go ahead, try it, please. So put some arrows at the end because this graph actually continues on forever and ever up top. Okay? Just like how the line continued on forever and ever, same thing here. Okay? Now, anyone want to help me with the next part? What's the y-intercept? 0. Good. The y-intercept where it crosses the y-axis, it's 0. What's the x-intercept in this case?
0.
Also 0. Yeah, just so happened to be that way. If I asked you to tell me the coordinates of the vertex, remember the vertex is that lowest or highest point.
0.
So yeah, 0, 0 in this case. Good. 0, 0. Now here's the interesting one. The equation of the axis of symmetry. Before we even give the equation, tell me where is the axis of symmetry? Where would you draw it?
Down the y-axis.
Yeah, use your hands. How would you draw it? Down the middle of the y-axis. Good. So can you draw in a dotted line here? And let's call this the axis of symmetry. Okay. And then I'd also like you to think about now, how do we describe this line using an equation? So this is back to now math 10 stuff. Don't know if you remember how to find the equation of vertical lines. Anyone want to give me a suggestion?
Something. Oh, y.
Why?
Something. MX.
mx plus b. That's the line that's kind of slanted, but this line's not slanted. This is going vertically. Undefined is the slope, true, but not the equation of the line. Let me ask you this. Tell me coordinates of the point here. What's this point? 0, 0. What's this point up here? Not 1, 1. Careful, I'm still on the y-axis.
0, 1.
0, 1. What's this one up here?
0, 2.
0, 2. What's the same?
The x is 0.
The x is 0. Bingo. This is the equation of the axis of symmetry. X equals to 0. Okay? What I'm saying to you is every single point on this vertical line has an x value that is always equal to 0, no matter what the y value is. So therefore, the equation is just x equals to 0. Okay? All right, let's keep going on. Domain, which was a term I think you learned last year, the possible values of x. What are the possible values of x of this parabola? Well, in this case, it's not just negative 3 to 3 because I put arrows here. If you look at the whole thing, it goes on forever to the left, forever to the right. What did we call that last year?
Oh, infinity something.
Infinity something? Or
Draw the infinity sign.
okay, well, there's two ways of doing it. You can say something like this. X is all real numbers. Do you remember doing this in Math 10 last year?
Just torture.
Okay, or sometimes teachers would use this notation. I don't know if you remember this notation. X belongs to the set of real numbers. So they have this sideways E that says belongs to. And then for real numbers, they use the letter R, but they use 2 bars. Remember that thing? Yeah. Or there was one more way of doing it. There was something called using interval notation. So you could have used something like this, negative infinity to positive infinity. Did you not do this last year in grade 10?
I did not. I'll give you those.
No? Which one looks familiar to you?
The first
Blue,
one.
green, or
Blue,
red?
Green and red.
Yeah, go ahead. Okay. Any one of these is fine, okay? I don't care which one you use. I don't prefer any of them. I'll take all of them, okay? How about the last one, range? What are the possible y values now? What are the possible y values of this graph? It's all this stuff up here, right? What would that be?
So 0.
0 or? Going which way? Less or more?
0 or more than
0 or more, right? You're looking at all the values that are 0 or more up here. Those are the possible y values. So to describe that, you would say, if you use that green notation, it'd be y, and y must be greater or equal to 0. Something like that, okay? If you want to describe this in words, you could say y is non-negative because it can't be negative. It has to be positive or 0. And if you like that interval notation style from grade 10, that would be you're starting at 0, okay, and you're going all the way to infinity. But I don't know if you remember this. When it's greater or equal to 0, I need to change one of my brackets.
well, the curve.
Yeah, instead of being curved, it has to be square. Did you guys not learn this last year?
I did not.
No,
Wasn't it a question on the provincial exam?
I can't remember.
Okay,
Mr.
all right.
Dimitrician told me.
Doesn't matter. This way is good if that's what you like. Okay, I'll take that. Now, don't turn the page yet because I want to go back now to finish off the top part. You know how I said here, after doing example 1, let's see if you can complete parts 4 and 5? Well, let me ask you this, okay? If I were to ask you to look at the coordinates of the vertex, okay? So in this case, this lowest point here. Okay. Now the y-coordinate of the vertex, which is this value of 0, I want you to understand that it determines the following. It determines either the maximum value, okay, or the minimum value. Right? It's either the highest point or the lowest point. And this depends on whether the parabola opens. Now, if it's a maximum, which way does it open? Up or down?
Up.
For a maximum.
Minimum is out.
Think about it. If it's a maximum, the parabola has to open downwards like this, right? That's the highest point. So we call this parabola opening downward because the opening is down here, okay? Whereas if the parabola opens up, and I'll draw the picture like this, now we have a minimum, okay? So that y coordinate of the vertex is actually quite important. It tells us a lot of stuff. And then the last part, number 5, the x coordinate of the vertex can be used to help determine what in this case? Not just the domain, but look at the x-intercept of the vertex. What
The
other
axis
thing
of
goes
symmetry.
through? Nice, Tanasia. It's the axis of symmetry. So the coordinates of the vertex can also be helped to determine the equation of the axis of symmetry. Excellent. And so these are the general properties of a quadratic equation or function. All right? These 5 points. And we're going to spend a lot of time talking about these quadratic functions, the next actually 2 chapters. Okay? But today, all I want you to be familiar with is what the function looks like, be able to graph things out, and take a look at the beautiful curve that you've learned today. Turn the page. Okay? It's time for you to be an investigative, investigative math student. I want you to think about what happens when I start changing things with this equation. For those of you who don't know me very well, I like chips. Okay? So when I teach this section, I talk about y equals x squared as the regular chips. Regular, plain, boring. Okay? I like different flavors to my chips. Barbecue, sour cream, sweet chili, and something else. Yeah, I was in China. They have lemon flavored chips. Yeah, they have cucumber flavored chips.
That's gross.
They actually tasted pretty good.
Wouldn't you rather just have a
They have what? Coca-Cola chips? I don't know about that. That's kind of dangerous.
kind of gross.
But in any case, I want us to think about this now. Okay, if this is the regular bag of chips, I'm going to now do something to it. I'm going to add something to it. Add some flavoring. Y equals x squared plus 3. What happens now with the graph when I've actually changed it by doing this plus 3?
The axis of symmetry.
Yes, Isabel. Maybe. We'll figure it out. Don't spoil the fun. Okay? So I would like you to do the following, please. Okay? Let's use those same x values, -3, -2, -1, 0, 1, 2, 3. And I'd like you to find the corresponding y values. Now notice I gave you 2 equations here. So the first one, I want you to use y equals to x squared plus 3. And I want you to find the table of values for that. Okay? And then if you're fast, you can then do the next one, y equals x squared minus 4, do the same thing. And then I'd like you to plot the actual coordinates on your grid, because I want to see the difference in the graphs. And let's see if Isabel's right. It goes up or it goes down, or it goes sideways or something else. We'll find out. Okay? So I'll help you with the first one. If I were to plug in -3 for x into this equation, -3 squared is 9. 9 plus 3 is 12. Good. Okay, and I'll do the next one with you. -2. -2 squared is +4. 4 plus 3 is 7. Thank you, Melinda. Next one, -1 squared is 1. 1 plus 3 is 4. Okay, and then continue to do the rest, please. And I'd like you to now graph this out. If you've got different colored pens, great, use them. If you don't, that's okay. You just need to label your equations well. Okay, now unfortunately 12 is not on this grid, so make it up somewhere. I don't know, up here. -2, 7. I'd like you to plot these, please, and then draw in your lovely picture. Let's see what you get. Okay. And can you do the same thing for the other one? 5, 0, -3, -4, -3, 0, and 5. Do you see a pattern, how it kind of goes down and goes back up? Can you see how it's the same? Because this is symmetric, remember? Symmetric about the axis of symmetry.
No, I just did it.
Okay. So I hope you've seen this in your pictures. And for those of you, by the way, who don't have colors, can you please label your graphs? Say y equals to x squared minus 4, and label the other one, because if I was to see this on a test, and I'd be like, well, yeah, you got some nice pictures, but which one belongs to which? I need to know that you also know. Okay, so label the equations if you can. Okay. By the way, what do you notice about the the y-intercept when you compare this equation in green to my regular one? What happened to the y-intercept?
Slower.
It's lower?
Oh wait, the green one?
The green one.
Oh, so it's higher.
It's higher. By how much?
3.
3. So it looks like it's higher by 3 units. Okay. And then if you compare now the other one, which is the purple one, you'll see that it is lower by 4 units. Okay. So this is the first thing I'd like you to understand. Okay. If you were to compare y equals x squared, and notice I've used this thing called q to represent that extra number at the end. If I were to compare this graph with y equals to x squared, which way does the graph move?
Positive.
Well, which way? Like
Up.
up or down? And in general, what do we use to describe things that go up and down? Starts with a V. Vertically, yes. The graph moves vertically. And if q is bigger than 0, so if the answer was positive, the graph moves which way? What's this way?
Up.
Up, good. So the graph moves up. Whereas if q is less than 0, the graph moves down. Okay? Now I'd like to show you something on the computer to try to help you even understand this even better. I'm going to use this program, and this program I think allows me to. Oh no, it lags. Let me erase that. Y equals to x squared. Cool. I can do this, and it's supposed to graph for me. There it is. Cool. I can make this bigger, I think. Oh yeah, bigger. I can give it a table. So look, there's your table of values, the one I actually told you to do. It's all here. Anyways, here's the neat thing about this program. Remember, this is the general one, right? I then said, why don't we add something to this, plus this q value, right? And then I could say, well, what happens when q equals to, and in this case was 4. Watch what the graph did, or does. I think, once it sees the number, oh, it's 4. There you go. Okay? I can change it. What happens if q was negative 3? It's down there. I can change it. What happens if q is, I don't know, negative 2.25? It shifted it down too. This is kind of boring. What happens if q was 0? Well, that's just the regular thing. What happens if I do something like this? I'm going to do this thing called the slider. And now what I'm saying is this can actually control my value of q. See, right now q is 0. So guess what? As I move this slider to the right, increasing q, what do you expect to happen with my graph?
The graph goes up.
Graph goes up? Let's see. Does the graph go up?
Yeah.
Yes. Woo! Bye. It's gone. No, no. Come back down. What happens if I go less than 0? Yeah, underneath. Are you getting sleepy? No, okay. So in any case, you've just proven to me that yes, the q value determines if the graph moves up or down. Cool. Don't you wish you had this program?
Yes.
Download it yourself. I only have a free trial version. I couldn't afford the real one. Anyways, let's go back to your notes. What happens with the next one now? Okay, now for this next one, I'm not going to ask you to make a table of values. I want you to watch me do this with the actual program. Okay? Notice what's the difference here now. Instead of having y equals x squared, now I have this thing where it's a bracket, and inside the bracket I've changed the x into x minus 2. So what do you think happens here? Well, let me go back to this thing. I will then erase this, erase, erase, erase. Cool. And what am I going to do now? I'm going to put something else around here. So x minus, oh, that looks like, that's not, doesn't like it. That's not a bracket. Bracket? No. X minus 2. Let's see if it makes sense. Oh, very nice. Cool. Hey, did you see what happened? No. You didn't see what happened? Try again. Watch. Okay, this is the regular one, right? Y equals x squared. Okay, before, and here's the after. X minus 2 all squared. Wait. There you go. What happened to the graph?
Move to the right.
Okay, moved which way?
To the right.
To the right. How many units?
Well, 2.
2 units. Okay, let's write this down, please. What happened in this case is it actually moved 2 units to the right.
Because of the square.
Is it because of the squared? I don't know. We'll figure this out. Now, can you also make a quick sketch of the parabola moving 2 to the right? So I'm thinking, let's take this point 0, 0, move it 2 to the right, 2, 0. I've got a point here which is -1, and I'm going to move that 2 to the right over here. And just try to do a quick sketch. I know it's not going to be accurate, but nonetheless, just do a quick sketch, please, of the parabola moving 2 to the right. Okay? And this one I'll say is y equals to x minus 2 all squared. Okay? Just do a quick sketch. It might not be accurate. That's okay. Just do a quick sketch. Wow. And then I'd like you to predict what you think will happen with the graph underneath. Y equals x plus 5 all squared. Okay, so see if you can do a quick prediction. So what do you notice about the x-intercept for that one? And I'm going to hopefully do this on that cool computer program. It's called Fluid Math, by the way. I do not own this. I did not make it. Someone else did. I just found it online. So what I'm going to do now is I'm going to replace this value. Let's get rid of that. Let me call this P now. And let me go P equals to 2. Okay? All right. So now I'm saying, hey, instead of having x minus 2, I want to now have x plus 5. Ladies and gentlemen, by the way, just if I were to ask you to rewrite this in a different format, because in my picture here I have x minus something, how would you rewrite that 5? How could you rewrite the 5 as something else with the minus? So if I write down x minus, what must this number in here be for it to be the same thing as positive 5? Anyone know? I'm just saying.
-5?
Yes, thank you, Milena. -5. Negative of a negative becomes positive. So what I'm trying to show you here is that this value in the box is actually -5. And the reason I'm doing that is because now I can plug in P for -5. What do you think is going to happen if I plug in -5? Which way does the graph move?
Left.
Boom, to the left. Good. So your picture in your notes should be this. For this one underneath, it moved 5 units to the left. And can you please do that quick sketch for me again? Move your unit from the origin here. So take your original parabola in red and move it 5 units to the left. So just kind of move everything 5 units to the left and just do a quick sketch. Doesn't have to be accurate. I'm not looking for accuracy right now. I just want you to have the general idea of what's going on. Okay? General idea. Okay. And let's see if you can also fill in the blanks where the box is then. Okay? By the way, everything in a box is important. Did I tell you my story about? Oh yes, okay. No more story. I'm sorry, I don't remember. I don't keep track. Did I tell you this? Yes. Did I tell you this? No.
I thought we were special class.
You are special. You're all special.
Oh God. You're all special in your own way, because your mommy
Yes.
told me.
Well, I don't know about that. Okay, so what happens with your graph when now I've changed the stuff inside the bracket? Which way does the graph move?
Horizontally?
Horizontally, good. Now, this next part is a little bit tricky, so please pay attention, okay? If the p-value is bigger than 0, the question is, which way does it move? And if the p-value is less than 0, which way does it move? Now, notice what p is. P is this value here inside the bracket, but notice the sign in front of the p-value is a negative. So let me now show you what I mean by that with this computer drawing, okay? Let me try to find that slider thing again. Slider, show number slider, there we go, okay? Right now, p is equal to -5, okay? Let me just change this to 0. Oh, it won't change my slider. That's not fun. Let's change this to 0, so it's back to normal, okay? Back to normal. Show the slider. Now, when p was 2, what happened? It moved to the right, right? It moved to the right. And when p was -5, it moved, right?
Wait, P was positive.
Okay, wait, was p +5 or -5? Here's the dilemma again. This is where it gets confusing, okay? Remember, when I go back to here, I'm always comparing the form x minus a number. What's that number in this case? That number for p is actually just 2, the regular 2. That number for p in this case is not 5, but -5, right? Because it always has to be in this form minus, okay? That's why it's confusing. If the p value is positive, that's the first example, like up here. What did we see? The graph moved to the right.
So it's a positive 2.
Okay.
Being percentage.
If it's less than 0, which is this example over here, then the graph moves to the left. Now, get this in your mind straight, because this is where people get confused. So please star this, okay? You either say to yourself, okay, I'm looking at the p-value, and the p-value always has to be some number with a minus sign in front. And if that's the case, then it goes to the right. If it's bigger than 0, it goes to the left if it's less than 0. Or, okay, and please underneath do this. I left you some space. Or, if you're going to look at the actual entire function and say x minus 2 all squared. So you see this x minus number, then yes, this also means you're going to the right. Where in this other situation, if you see this plus a number, okay, you see this plus a number, that means it goes to the left. It's up to you what you prefer, but choose one way to understand this and use that from now on. Either your question is find the p-value and do this, or look at the entire thing inside the bracket, and if you see a minus, that means it's going to the right. If you see a plus, that goes to the left. It's your choice. Okay. Tell you, this is the weird part. Okay. All right. How are we doing so far? Are we okay? Did I bore you to death? Always. Okay. Let's move on. Okay. Let's move on. I've got a few more minutes. Let's see if I can finish at least page 3. Okay, dear friends. What happens now in this case now? I'm going to ask you to graph out this function. Ew, this looks even more scary. Regular chips with one flavor and another flavor. 2 flavors. What are my 2 flavors?
Barbecue and chicken wings.
Barbecue and no, in terms of the math. What are my 2 flavors? First of all, what does this plus 2 represent? Going 2 which way?
Right. Up.
Up. Good. So that plus 2 means the following. You moved, and please write this down, 2 up. Okay, what about this x minus 3 thing here? Tricky.
Goes to the right.
I'll tell you it's 3, but which way? To the right or to the left?
To the right. 'Cause it's minus.
To the right. Awesome. So, if I asked you to compare this with your y equals to x squared function, okay, 0, 0 was the vertex for x squared. Remember, it's always the one that goes to the origin, 0, 0. What's the new vertex of this equation going to be? If I'm going to say move 2 up, 3 to the right. Isabel.
3, 2, minus 3.
But what are the actual coordinates of the vertex?
3, 2.
So I go 3 to the right. Not 2 minus, but I start with 0, 0. So I go 2 up, which means the y coordinate goes up by 2.
3, 2.
Right? Okay, so that would be 2 for the y. And what would be my new x coordinate then?
3.
3. Good. So I'm really just following the steps here that I wrote down, and for every single point from the regular graph, I now shift it 2 up, 3 to the right. So let's just go ahead and do that. Let's just write down our vertex of 3, 2. It's up here now. And let's just do a quick sketch. Your parabola looks something like this. Okay? That's all. That's kind of off? You're right. Since I'm recording this online, I better make this look nice. There you go. Okay? Just a quick sketch. It doesn't have to be exactly the same thing. Huh. I'm curious about this point down here. We have a special name for it. What is it called?
Axis of symmetry.
Not the axis of symmetry. That point is just the vertex. Good. The line that goes through that point is the axis of symmetry. You're right. So it looks like that's the vertex, and the coordinates of the vertex here are 3, 2. So my question to you then is this. If I were to now write the equation of a parabola as this ugly thing, y equals to, with a bracket, x minus p all squared plus q, what do I describe, or how do I describe the p and the q? What is that called?
So one.
It's the x and y coordinates of the
Vertex.
vertex.
Oh, sweet.
Yes. Okay? So P and Q are the x and y coordinates of the vertex. Okay, so my question to you now is, well, what do you think happens now if I were to switch it up on you? And I'm going to say, write an equation of a quadratic with the given vertex. So my question to you is, hey, what's my P and what's my Q if you look at this? What's P? P equals to -1. Good. What's my Q value? That's the 3, right? Because those are the coordinates of the vertex. So knowing those two things, can you now write the equation for me? So let's use the stuff in the box above. What's the equation? Y equals to?
X plus 1 squared.
Good. So I'm going to write down one more extra step here. X minus -1. But Tanasia correctly said that, hey, that's just the same thing as x plus 1, so that's perfectly fine. If you can skip a step, that's okay. For those of you who don't want to, then you can write out both things. So anyways, the equation then just becomes y equals to x plus 1 all squared plus 3. And there you have it. You now know how to go the other way around. Okay? All right, let me just try to finish off investigation number 3 and we'll stop for today, okay? Because I'm taking too much time. Okay, guess what? I have 3 other ones I want you to draw out. The first one, y equals to x squared, is done for you. It's here, okay? You see all that empty space? It's because I want you to make a table of values. Okay, and I want you to graph this out with these values. So please copy this in that empty space. I know you will hate me after today, but that's okay. I have lots of friends. Okay, and then I'm going to ask you to graph out all of the other ones. Y equals 2x squared. And then I'll ask you to do y equals to 1/2 x squared. And I'm going to ask you to also graph out y equals to -1/2 x squared. Make a table of values for all of them, plot the points, and then sketch the graphs. Go for it. So the first one is 18. The next one, -2 all squared is 4. 4 times 2 is 8. Okay. The next one is -1. -1 squared is 1. 1 times 2 is 2. 0, well that's just 0. And guess what? The rest are the same. Okay, so try these please. Okay, I'll do the first one for the next one as well. -3 squared is 9. That's 9 over 2. Or 4.5. 4, it's 2. Okay, keep going. Try this stuff on your own. Don't wait for me. Okay, once you've got the table values, don't forget to make sketches. You should only be able to do, I'll only assign one question for you for homework.
I really hate this commercial. What should be like 357 ounces?